Hello. Today we will be talking about section 7.6, solving exponential equations. To do this, we need to talk about the one-to-one property of exponents. It says, if b to the x power equals y to the x power, then x equals y. And this is true when b is greater than 0 and b does not equal 1. So in order to do this, we need to be able to write both sides of the equation as a base written to a power. Now we'll see on problem 1 that we have 5 to the n power. So that is already written in the way that we need, but we need to change that 125 so it's a base written to a power. Now we're trying to get that base to be 5 because they need to match. Notice up here that our bases match each other. They're both base b. So if you're unsure on how to write that, we can start by doing a prime factorization. So take 125 and ask yourself, what times what is 125? Well, it ends in a 5, so I know 5 divides into it, and it divides in 25 times. 5 is prime, so that one stops there, but 25 can still be written as 5 times 5. Now we have it written as all prime factors, and 5 times 5 times 5 can be written as 5 to the third power. So we'll have 5 to the n power equals 5 to the third power. And then according to this one-to-one property of exponents, since our bases are the same, we can set those exponents equal to each other. And we do that, we see that n equals 3. And so that would be our solution. All right, let's look at the next one. This time we do have the bases already the same, so we don't need to do that. But we're going to use this property to set the exponents equal to each other. So meaning I'll have x minus 3 equals 2x plus 5. And then I just need to solve this for x. So let's subtract x over, and let's also subtract our 5 over to the left side, which will give us negative 8 equals x. And so there we have our answer for this one. So if I plug 8 in here, I could check to make sure that it is, in fact, correct. So let's look over here just to do the check on this one. So if I have 4 to the x minus 3 power, that means I'll have 4 to the negative 8 minus 3 power. And on the other side, I'll have 4 to the 2 times negative 8 plus 5 power. So on this side, I get 4 to the negative 11th power equals 4 to the 2 times negative 8 is negative 16 plus 5 is negative 11. So I do get the same thing on both sides. That means that, yes, this is a good solution. All right, let's look at another one here. This time we have our base is a fraction. And so when we have a fraction like this, we notice that it's 1/3. And our base on the other side is 3. So we need to ask ourselves, how could we get this to be the same? Well, remember that 3 to the negative 1 power is 1/3, right? Or 1/3 to the negative 1 power gives us 3, as it just flips it. Let's keep this in mind as we're working this next problem. So now, if I want to change this 1/3 to a base of 3, I need to take the reciprocal of it. And so I'm going to have something kind of like this. So I'll have 3 to the negative 1 power. Remember, that's the same thing as 1/3. And then that's going to be multiplied, that negative 1 is going to be multiplied by the rest of our exponent there, the x minus 9. And now I have 3 to the 6x minus 7 power on the right side of the equation. All right, so now I can see my bases are the same. Now I can set those exponents equal to each other to solve. So let's do that. And on this one, I can go ahead and distribute that negative 1 through when I'm setting them equal to each other. So what does that give us here? Well, we'd have negative x plus 9 equals 6x minus 7. And then if I'm trying to solve for x here, let's go ahead and add x to the right side. And let's add 7 to the left side. Well, that's going to give me 16 equals 7x. Now one more step that we need to take here to get x by itself. Let's divide by 7. And that will give me x equals 16/7. Now your answer can come out to be a fraction. Don't let that worry you. Fractions are perfectly good answers.